Right at this very second, the light hitting your skin and passing through your eyes is triggering this massive, completely invisible cascade of chemical reactions inside your body.
Oh, absolutely. Nonstop.
Yeah, and we usually think of light as just, this thing that helps us see the world around us. Or maybe it just keeps us warm on a sunny day. It feels so external, right? Like it's just this passive thing. But today, we are going to completely shatter that basic assumption.
We really are. It requires a pretty profound shift in perspective, honestly, because we have to stop looking at light purely as illumination.
Right.
What the latest metabolic research is revealing is that we need to start recognizing light for what it truly is, which is a biological necessity.
Welcome to the Deep Dive. Today we are unpacking an incredibly dense, just fascinating area of science. Specifically, we're looking at the biphasic modulatory effects of the electromagnetic spectrum on human metabolism.
A very wordy title, I know. Seriously wordy. But our mission today is to show you that light is a literal physical nutrient. I mean, it drives your cellular respiration, it alters your hormones, and it even dictates your blood sugar levels.
Yeah, so think of human biology as a highly sensitive transducer for the electromagnetic spectrum. We are in this constant, non-stop exchange of energy and information with our environment. The light around you isn't just bouncing off you, it is entering you. It's communicating directly with your cells and driving the core machinery of your metabolism.
Okay, let's unpack this, because researchers use a very specific framework to explain how this works, and they call it infinite fractal descent, or IFD.
Right, IFT.
And if we think of light like food, it doesn't just hit us and disappear. Just like a heavy meal breaks down from those big macronutrients, the proteins and the carbs, into tiny microscopic molecules to feed our individual cells, light does something really similar, but basically in reverse.
Exactly. It's a bottom-up process. Yeah. It hits us at the absolute smallest quantum level, and then that energy cascades all the way up to change our whole mood.
The infinite fractal descent is just such a beautiful framework for conceptualizing this process. It posits that electromagnetic energy cascades across multiple biological scales, pushing this incredible chain reaction.
Signed upward.
Right. So it starts at the very bottom, which we call the quantum scale. This is where a single photon of light is absorbed by specific molecular receptors in our body, which we call chromophores.
Like little biological antennas, basically, just waiting to catch a specific frequency. But what are these antennas actually doing when they catch it?
They are structurally altering themselves. So a primary example of this is an enzyme in our mitochondria called cytochrome C oxidase.
Okay.
When that single photon is absorbed by the enzyme, it triggers the next level up, which is the molecular scale. The photon literally imparts energy that changes the chemical behavior of the cell itself. This means upregulating ATP, which is, the core energy currency of your body. Or it could be releasing signaling molecules like nitric oxide.
So a microscopic particle of light hits an antenna, and suddenly the cell just starts churning out more energy or pumping out chemical messengers.
That is the exact mechanism, yeah.
Yeah.
And those molecular shifts, they don't just stay isolated because your individual cells are changing their behavior. The cascade moves up again to the systemic scale.
Like system-wide changes.
Exactly. Your overall blood glucose clearance changes, or your vascular resistance drops, so your blood flows easier. And finally, that manifests at the macro scale, the very top level.
Which is how we actually feel, right? Like our behavior, our vitality, our mood.
Spot on. When you step outside on a bright, sunny morning and you suddenly feel that rush of alertness and energy, that isn't just a psychological reaction to a nice day.
It's not just, oh, I'm happy the sun is out.
No, not at all. It is a mathematically precise cascade that started at the microscopic level of your mitochondria and rippled all the way up to your conscious mind.
It really makes you look at a sunbeam completely differently. And what's wild is that different types of light trigger entirely different cascades.
Oh, completely different.
So let's look at the highest energy light that hits our skin first, which is ultraviolet or UV light. I mean, most of us know about UVB light, the kind that gives us sunburns if we aren't careful, because it synthesizes vitamin D in our skin.
Right, which we need for calcium in our immune system.
Exactly. But there's a completely separate reaction happening at the exact same time involving something called the POMC gene.
Yeah, pro-opiomelanocortin, or POMC, is a very specific gene in our skin cells. When the high-energy photons of UVB light hit your skin, it triggers this gene to express a protein that gets cleaved or, cut up into several different active peptides.
Okay.
And one of those resulting peptides is beta-endorphin.
Here's where it gets really interesting, because when I first read about this, I mean, I had to do a double take. Beta endorphins are opioids.
They are endogenous opioids, yes.
So wait, does that mean people can get addicted to the sun? Like an actual drug?
It is a heavily documented phenomenon, actually. We call it solar-seeking behavior. Because UVB exposure triggers the release of beta endorphins, the sun is literally providing an analgesic, pain-relieving, opioid-like effect to the entire body.
That is insane.
It's fascinating. You actually experience mild withdrawal symptoms when cut off from it. Your biology is rewarding you chemically for standing in the sun.
That is mind-blowing. But I want to understand the why here. Evolutionarily, why would our bodies drug us just to get us to stand in the sun?
It ensures survival. I mean, if we stayed hidden in caves all day, we wouldn't synthesize enough vitamin D to maintain our bone density, and we'd literally die out.
Oh, so it's a bribe.
Basically, the endogenous opioid reward system guarantees we seek out the exact environmental exposure we need to thrive.
And it doesn't stop at just making us feel good either. There's this concept in the research of a skin-brain gonadal axis that gets activated by that exact same UVB exposure.
Yeah, this is where we see how deeply intertwined light is with reproduction. Studies on both animals and humans show that UVB exposure actively increases levels of sex steroid hormones.
Right.
The skin detects the light, sends a signal to the brain, and the brain tells the gonads to ramp up production. In men, it significantly boosts testosterone.
And in women.
In women, it boosts anti-Müllerian hormone, or AMH, which is a really key marker of ovarian reserve.
So the sun is actively enhancing romantic passion and sexual responsiveness.
Oh, yeah.
Just by hitting our skin.
It acts as a massive environmental cue. The light is essentially signaling the body, it's summer, food is plentiful, conditions are optimal for vitality and reproduction, so ramp up the systems.
Incredible. Okay, so now if we move just a little bit further up the spectrum to UVA light, we get an entirely different reaction. UVA is still invisible to us, but it doesn't make vitamin D, right?
Correct. Instead, it hits the skin and facilitates the release of nitric oxide into our bloodstream.
And nitric oxide is, it's a vasodilator, right?
Yeah. A very potent vasodilator. Its primary job in this context is to tell the smooth muscle lining your blood vessels to just relax. And when those muscles relax, the vessels widen and your blood flows much more freely.
There was a clinical study on this in the sources that honestly sounded like science fiction to me. They took subjects and gave them a whole body dose of UVA light.
Just a moderate dose, too.
Right. Roughly 20 joules per square centimeter. And within just 30 minutes, both their systolic and diastolic blood pressure plummeted.
And we know exactly why it happened. That single 30-minute exposure increased the concentration of nitric oxide species in their blood plasma by a staggering 74%.
74% from just standing in front of a light.
Yes. Because their blood vessels widened so dramatically, their forearm blood flow actually increased by 26%.
It's acting like a pharmaceutical blood pressure medication just delivered through a light bulb.
Or, well, the sun, originally.
And all of this happens completely independently of any vitamin D synthesis. The UVA photons are acting directly as a mechanism for cardiovascular regulation. Okay, so invisible UV light is doing all this heavy lifting for our hormones and blood pressure during the day. But I want to pivot now to the light we actually see, the visible spectrum.
Ah, yes.
Specifically, blue light. Because I'm a little confused here. I get targeted ads every single day for blue light blocking glasses, and they treat blue light like it's this toxic poison. But our eyes literally have receptors built specifically for it.
They absolutely do. Blue light is what chronobiologists call the primary Zeitgeber, which is a German word meaning time giver.
Time giver, okay.
Yeah, it is the master clock setter for human circadian rhythms. We have these specialized cells in our eyes, intrinsically photosensitive retinal ganglion cells that contain a protein called melanopsin.
And they don't help us see, do they?
Not really, no. They don't help us see shapes or colors. They exist almost entirely to detect blue light and tell the brain the sun is up, it is daytime.
So blue light isn't inherently a toxic thing like pop culture sometimes implies. It's purely a timing issue.
Exactly. If we connect this to the bigger picture, during the day, blue light is optimizing our cognitive function and keeping our metabolic rate up. The issue is purely an evolutionary mismatch regarding timing.
Because of artificial lights.
Right. For millions of years, the only time human biology experienced bright blue light was when the sun was high in the sky. When the sun went down, the blue light vanished.
But today, we have Alan, artificial light at night.
Yes. We sit under bright blue LEDs and stare at laptops at midnight.
We're basically telling our brain it's high noon, but our body is desperately trying to shut down for sleep.
And that systemic confusion creates metabolic chaos. To understand the scale of this, we can look at a massive UK biobank study. They didn't just ask people how much light they used at night.
Oh, they actually measured it.
Yes, they put actigraphy monitors, highly sensitive wrist-worn light sensors on over 84,000 people and tracked them for years.
That is a massive data set. So what did the sensors actually show?
The results were stark. They found that exposure to brighter artificial light at night significantly increases the risk of incident type 2 diabetes. The hazard ratio was 1.53 for the highest exposure percentiles.
Let's translate that number for a second. A hazard ratio of 1.53 means the people getting the most blue light at night were 53% more likely to develop type 2 diabetes compared to the people sitting in the dark.
53% more likely.
That's huge.
It is. It also drove up their risk for cardiovascular diseases. The artificial light at night disrupts insulin sensitivity and glucose metabolism at a fundamental cellular level.
Wow.
But conversely, the exact same study found that people who got the brightest light during the day had a lower all-cause mortality risk. So the light isn't toxic. The timing of the light is toxic.
Which brings up a huge question for me. If artificial blue light at night is causing this much metabolic damage, spiking our blood sugar, confusing our insulin, what is the biological antidote?
The antidote lies further down the spectrum.
Right. This leads us to the other end of the visible spectrum. Long wavelength radiation, red and near infrared light.
This is where we move completely out of the superficial layers of the skin. Long wavelength radiation has incredible penetration depth. Visible red light gets deep into the dermis, but near infrared, or NIR light, goes much, much further.
How far are we talking?
The photons can travel up to 30 millimeters into biological tissue. That means it easily passes right through your skin and into your muscle layer, your tendons, and even your bones.
And it does this without causing any of the high-energy DNA damage or sunburns that UV light can cause.
Right. It's totally safe in that regard.
So what are these deep penetrating red photons actually doing when they reach our muscles?
We go back to that molecular antenna we mentioned at the very beginning, cytochrome C oxidase. It is the terminal enzyme in the mitochondrial electron transport chain. When we are stressed or aging or dealing with systemic inflammation, nitric oxide actually binds to this enzyme and puts the brakes on our cellular energy production.
It sort of gums up the engine so the cell can't make ATP.
Exactly. It's stuck. But when a photon of red or near-infrared light is absorbed by that specific enzyme, it provides the exact amount of energy needed to photodissociate or physically break off that inhibitory nitric oxide.
Wait, it literally kicks the nitric oxide out of the way.
It kicks it right out. It unbreaks the respiration process. Suddenly, the mitochondrial membrane potential increases, and the cell massively upregulates its production of ATP energy. It's like throwing the engine back into high gear.
Which brings me to what might be the most staggering study in this entire deep dive. There was a 2024 study by researchers Powner and Jeffrey.
Oh, the glucose challenge study.
Yeah. They wanted to see how this burst of cellular energy affected our blood sugar. They took subjects, gave them a glucose challenge, which basically means making them drink a huge concentrated dose of sugar water, and then they just shined a specific red light on their bare backs for 15 minutes.
Just 15 minutes of light. And the results were immediate and highly measurable. That single exposure resulted in a 27.7% reduction in total blood glucose elevation over the next 2 hours.
That's crazy.
Furthermore, the absolute maximum glucose spike itself was reduced by 7.5% compared to the control group who didn't get the light.
So what does this all mean if I'm translating this into daily life for you listening? You literally shine a red light on your back for 15 minutes, and your body burns through the sugar in your blood 27% faster simply because your mitochondria are demanding more fuel.
The mechanism is profound but really straightforward. By unbreaking the mitochondria across a large area of muscle tissue like your back, you drastically increase the cellular demand for glucose.
Because the engine is running faster.
Exactly. The cells act like a sponge, pulling the sugar out of the bloodstream to fuel this newly accelerated ATP synthesis. But there's another nuanced detail about near-infrared light that I really love that goes beyond just energy production.
Oh, let's hear it.
It acts directly on our immune system. Specifically, it alters the behavior of white blood cells called macrophages. When a tissue is injured or chronically inflamed, macrophages flock to the site and adopt what we call an M1 phenotype.
Okay, what does that mean?
This is the pro-inflammatory attack mode. They clear out cellular debris, but they also cause swelling and collateral damage in the process.
They're like the demolition crew.
That's a very good analogy.
Yeah.
But near-infrared light actively forces these macrophages to polarize, shifting them into an M2 phenotype.
And M2 is better.
M2 is anti-inflammatory. It's the reparative tissue healing mode. The photons literally change the metabolic profile of the macrophage, causing it to stop attacking and start releasing growth factors. It supports the growth of new blood vessels and lays down new collagen.
It's like flipping a switch in your immune system from demolition mode to reconstruction mode.
The light triggers a complete behavioral profile shift in the immune cell. It's amazing.
Okay, but this raises a very obvious question for me. If red and near-infrared light is this miraculous, deep tissue healing, blood sugar lowering magic, why not just blast ourselves with it 247? Why not install high-powered red lights in every room and just leave them on all day?
Because we have to remember that light is a nutrient, and therefore it obeys the exact same pharmacological laws as any other nutrient or drug.
Dosage.
Yes. The research explores this through something called the Arndt-Schultz law.
Which deals with the biphasic dose-response curve, right?
Yes. The Arndt-Schultz law dictates that weak stimuli accelerate physiological activity, whereas strong stimuli inhibit it or even cause damage. It looks like a bell curve.
Like a Goldilocks situation.
Perfectly said. There is a perfect Goldilocks zone for light exposure. For red light, it's typically around 5 joules per square centimeter. In this zone, the light acts as a hermetic stressor of beneficial stress. It triggers a small, controlled burst of reactive oxygen species inside the cell.
And those act like an alarm bell, waking the cells up and telling them to build up their antioxidant defenses.
Right, it promotes cellular homeostasis and resilience. But if you think, more is better, and you push past that limit, say you blast yourself with 50 joules per square centimeter, or you use a very high-powered laser over 300 milliwatts per square centimeter, you fall off the backside of the bell curve.
The research calls this the ROS bottleneck, right?
No.
Too many reactive oxygen species.
Yes. The electron transport chain gets overstimulated to the point of absolute failure. Electrons start leaking out of the mitochondria, resulting in excessive oxidative stress. Instead of signaling for repair, this massive oxidative stress damages the mitochondrial DNA.
So too much of a good thing becomes a very bad thing.
It actually goes deeper than that. Extremely high irradiance can actually cause thermal degradation of collagen by upregulating matrix metalloproteinases.
Wait, hold on. Matrix metalloproteinases, those are the enzymes that chew up collagen, right?
They are.
So you're saying blasting too much red light literally melts the collagen that keeps our skin looking young and healthy.
Essentially, yes. The excessive energy causes the tissue to break down its own structural proteins. This thermodynamic limit establishes the strict boundary conditions for how energy translates into a biological benefit.
So dosage absolutely matters. But the science points out an even bigger problem with our modern lifestyle. It's not just that we are getting too much or too little light overall. It's that we are getting a completely unnatural recipe of light.
Our light diet is terrible.
Yeah, there's this concept in the sources of spectral buffering and red starvation.
Evolutionarily speaking, natural sunlight always provided spectral buffering. What that means is whenever the sun delivered high-energy ultraviolet or blue light to our eyes and skin, it was always accompanied by a massive protective dose of red and near-infrared wavelengths.
So they came together.
Always. The stimulating high-energy frequencies were naturally buffered by the healing, reparative frequencies.
There's a spectral chart comparing natural sunlight to a modern office LED light, and it is honestly terrifying to look at.
It's a stark contrast.
If you look at sunlight, the graph looks like this smooth rolling hill across the entire spectrum. It has everything. But if you look at the modern LED bulb light in your office or your kitchen, it has this massive jagged spike in the blue range, right around 450 nanometers, and then it just flatlines. It is completely devoid of any red or near-infrared wavelengths.
By transitioning to energy-efficient LEDs, we have inadvertently engineered a modern pathology termed red starvation. We spend our days bathed in isolated blue light spikes, suffering from a profound deficiency of the reparative red frequencies that our biology expects.
It's like drinking 5 shots of espresso on an empty stomach. In nature, the espresso of blue light was always served wrapped in a heavy, protective meal of red light. But our modern office LEDs are just serving us the pure espresso, and our cells are basically vibrating themselves to death.
I love that analogy. And the physiological consequence of that pure espresso diet is exactly what the IFD model predicts. That severe lack of near-infrared photons reduces mitochondrial respiration, it impairs cellular repair, and it drives the global rise in chronic oxidative stress and insulin resistance we are seeing today.
We are living in an artificial light environment that completely ignores the fractal architecture of our own bodies.
We really have. We have fundamentally decoupled ourselves from the electromagnetic diet that dictated our evolution.
So let's step back and summarize this incredible journey we've just been on. We started by looking at light purely as a tool for illumination. But the data shows us that light is a fundamental metabolic
A
nutrient.
physical nutrient, yeah.
It follows a fractal descent, cascading from a single quantum photon hitting a microscopic antenna in our cells, all the way up to the release of natural opioids and sex hormones, the dropping of our blood pressure, and the aggressive clearing of glucose from our blood.
And the overarching takeaway is that timing and spectral balance are everything. We absolutely need bright blue light during the day to set our clocks. We need to strictly avoid it at night to protect our metabolism. And we desperately need to reintroduce the protective, energy-boosting red and near-infrared frequencies that our modern indoor world has stripped away.
A lot of complex biology to process, but it empowers you to look at your environment totally differently.
I actually want to leave you with a forward-looking thought that builds directly on these mechanisms. If we now conclusively know that light is a measurable biological nutrient one that lowers blood sugar and dictates hormones, subject to the exact same dose-response laws as a pharmaceutical drug, this raises an inevitable question.
Okay, what's the question?
How long will it be until indoor lighting systems are literally prescribed by doctors?
Wow, that's a wild concept.
Think about it. Imagine a future where you go for a checkup and your physician doesn't just hand you a pill for your high blood pressure or your prediabetes. Instead, they upload a prescription to your smart home.
Wait, really?
Yeah. And your house automatically adjusts the exact spectral diet of your living room lighting, shifting the balance of blue, red, and near-infrared wavelengths minute by minute based on real-time data streaming from your continuous blood glucose monitor.
A completely customized atmospheric medicine. That is unbelievable.
But the physiological science is already proven. It's just a matter of engineering our indoor environment to match our biology once again.
That is definitely something to think about. Next time you flip a switch in your house or sit down at your desk, take a second to look at the light bulb above your head. What kind of meal are you feeding your cells right now? Are you giving them the balanced, buffered nutrition they evolved to expect, or just a jagged spike of pure stress? It is entirely in your hands. Thank you for joining us on this deep dive.